Welcome to week 2 of Geometry SOL Review. Today we will be talking about parallel lines and transversals. Let's start with just a quick refresher on what we learned earlier this year. Anytime you have a line that crosses two or more lines, similar to this one, this is what we would call a transversal. And as you can see, these two lines that are both going horizontal would appear to be our parallel lines. Remember, parallel lines never touch or intersect each other. Let's go over a couple of really important angle pairs when dealing with these kinds of diagrams, these parallel lines with transversals. Let's look at angle 1 and angle 8. For a little while I'm going to be talking about inside and outside. When I refer to the inside, I'm talking about in between our two parallel lines. But you can see that these two angles, 1 and 8, are not even in between them. That's why they're going to be considered the outside, anything above or below. If this diagram were turned sideways, it would be the left and right and the middle as well. But inside is always between your two lines, outside is not in between those two lines. So as we can see right now, 1 and 8 are both in the exterior, they're in the outside. These are considered alternate exterior angles because this transversal has one of these angles on the left side and one on the right side. They are alternating in the exterior, which makes them alternate exterior angles. Another important pair of angles to know, which are very similar to these, are alternate interior angles. Note, these are on the outside, so if we had a pair like 6 and 3, they are on the inside. One is to the left of your transversal, one is to the right of your transversal. They are alternating on the inside, alternate interior angles. What about 8 and 4? These angles are what I would consider to be the same spot. You can't see me right now, but I'm using air quotes when I say the same spot. Notice at each intersection you divide things into 4 sections. 4 is in this bottom right spot, 8 is also in this bottom right. 6 and 2, they're in the top right, 1 and 5 top left. Just as long as they're in the same spot, again, air quotes, in their intersections, they will correspond. So this angle right here corresponds with this angle right here. They're both in the bottom right. They are corresponding. These angles will be congruent. The last pair that really matters when we're talking about parallel lines and transversals are going to look like this. 4 and 6 are both in the interior, but they're not alternate interior angles because they're both on the same side of the transversal. This means they are consecutive interior angles. Two more quick angle pairs that are really important in this unit and will work in pretty much every unit. If we look at angle 7 and angle 6, notice we don't even need this top section right here. Any two angles that are across from each other are vertical. These are an important pair of angles to remember. You'll see these in triangles all over the place. But whenever two angles at a single intersection are directly across from each other, they are considered vertical angles and they are considered congruent. Last pair of very important angles. Again, doesn't have to deal with parallel lines, but you'll see them a lot and this pattern is helpful. If we look at angle 1 and angle 2. They are directly next to each other. We consider them adjacent angles. But because they share a line, this horizontal line right here, 180 degrees makes up one side of a line. And if two angles are directly next to each other and share the same line, they are called a linear pair. These angles are supplementary. They add up to be 180 degrees. Now, to the right of this diagram, you have a box with a whole bunch of different angle pairs. Now that we've done a quick review, see if you can match up which ones belong with which. Take the next minute or so, enjoy some music, and see if you can figure out these next few pairs. back. What I've done, and this is what I would usually do if I have time and all sorts of different colors, is I will color coordinate what I am looking at. Now obviously on the SOL I think you only get one highlighter color, but because we have 6 different problems, I decided to go all different colors on you. I'm going to break this down one by one, talk about how we can recognize which one is which, and that's what we'll do. Angles 1 and 4, that's in red right here. Notice they are directly across from each other. They only use one intersection. It doesn't use both lines. That will usually clue you in whenever it's just one of these, that it's either going to be vertical or a linear pair because they're directly across from each other. Angles 1 and 4 are vertical angles. Angles 3 and 5 in orange. I notice right away these orange angles are in the interior. They're in between our 2 lines that will be parallel. That narrows it down to either being consecutive interior or alternate interior. And in this example, 3 and 5 are going to be consecutive interior angles. This is because they are both on the same side of our transversal. They're both on this left side. They don't alternate. 2 and 7 in yellow, up here and down here. They are in the exterior. They're both in the exterior of our diagram here. 2 is on the right side of our transversal, 7 is on the left because they alternate. They're on opposite sides of our transversal and they're in the exterior. We're looking at a pair of alternate exterior angles. 4 and 5 in green, right here and right here. Again, these are both on the interior, and you'll notice 5 is on the left side of our transversal, 4 is on the right. This makes them alternate interior angles. 6 and 8, they're right down here. They don't even use this top intersection. They are right next to each other. They're adjacent angles, and they share this line. Because of all those things, they are a linear pair. They will be supplementary angles. And lastly, in purple, 1 and 5, or 5 and 1. I notice that we have one in the exterior and one in the interior, so that's going to rule out alternate exterior, alternate interior, and consecutive interior. Can't be those because you can't have one on the inside and one on the outside. What you do see though, 5 is in this top left part of the intersection, 1 is in the top left part of the intersection. Because they are in air quotes the same spot, you're looking at corresponding angles. For some of you who are looking at this, seeing this diagram with all these colors, you're like, no way am I going to remember all these things. Cool, because that was the math way. We're now going to do the SOL way. Lines are parallel if and only if. Don't forget, if and only if means it is a biconditional, and that means this is true if the stuff I'm about to write is true, and vice versa. So, you know your lines are parallel if big equals big, small equals small, or a big plus a small equals 180. Write that down, and then I'll go back and explain what this means. What do I mean by big and small? Well, we have a whole bunch of different angles here. I'm actually going to jump back to this diagram because it's nice and plain and boring. What I want you to point out and notice is no matter where these angles are all going to line up, you are going to have obtuse angles, meaning angles that are bigger than 90 degrees. I'm going to highlight those in green right now. That's what we will consider our big angles because they're bigger than 90. Big. Our small angles, meaning anything that's acute, can be highlighted in red right now. Small. So if you remember all of your angle pairs, we had alternate interiors similar to 4 and 5. Those would be congruent, well, big equals big. The green ones are the same. We had alternate exterior angles like 7 and 2. Small equals small. And then there were a few different types of angles that were going to be supplementary. A big plus a small will equal 180, like 4 and 6. These angles were consecutive interior angles. One's bigger than 90, one's smaller than 90, but they will always add up together to be 180. Similarly, are linear pairs, like 7 and 8. They're right next to each other. They share the line. One big, one small equals 180. So again, you can remember the math way, or we can remember the SOL way. Big equals big, small equals small, big plus small equals 180. Let's try this, thinking along these lines. You can see a lot of diagrams like this, because most of the time they're not going to be nice and pretty with just two lines. They're going to have a whole bunch of them, and you're going to have to find out, well, how can I tell if these are parallel? Remember, big equals big, small equals small. Big plus small equals 180. So let's take a look. I'm going to label these with my highlighter, and you can do this on your SOL because, again, you'll have one color. So label one highlighted and label the other not highlighted. Let's make big, oops, that's not a highlighter. Let's try that again. Highlight your big angle. You know 110 is bigger than 90. Follow this pattern. Starting here, go directly across from it, and then go back and forth and back and forth. Some people call this the zigzag method, some call it the lightning bolt because it kind of resembles a lightning bolt like that, but I call it a checkerboard because checkerboards have opposite colors like that. So all of these would be considered your big angles, and all of the other ones, the ones you didn't highlight, are considered your small angles. In order for two lines to be parallel, again, this works in both directions. If you can prove one of these things is true, then you know your lines are parallel. So, do we have any big angles equal to any other big angles? Well, in this case, we only have one big angle. This is the 110, and nothing else has been labeled to match it. So we're not going to use that one. Let's take a look at our small angles. Nothing here, nothing here. 65, nothing, nothing, and 70. Small should equal small. Well, are 70 and 65 the same thing? I want you to notice 70 is touching this line N, 65 is touching M. Because these are not equal, small does not equal small, we know M will not be parallel to N. A couple more ones we can check. But for this one, we have to check if big plus small equals 180. So look at L. We haven't done anything with L yet. It has an angle of 110. This is a big angle. This is a small angle. Does 110 plus 65 equal 180? It actually equals 175. So because big plus small does not equal 180, the line that this is touching, L, will not be parallel to M. L is not parallel to M. Put a slash through it. It means not parallel because those two lines mean parallel. One more one we can check. We've checked M and N. We've checked L and M. Let's check these outside ones. Again, we have one big and one small. Is it true that 110 plus 70 equals 180? That is true. Because one big plus one small equals 180, the only two lines that we have parallel here are L and N. So if you were looking for a pair of parallel lines, that is how you would do it. One more type of example. Lots of lines could be parallel. We have C and D and E and F. We're trying to show whether or not two lines are parallel. And some of you are looking at this going, I don't even know where to start. That's cool. Now you can't see my hands right now, so I have to do this the only way I know how to. But your goal is to cover up stuff that you don't need. Watch. Pretend this black box, this rectangle, is your finger, or a pen, or a pencil, or a piece of paper, anything. You want to cover up one line and all the information on that line and focus on what you have left. Take a look. You have two parallel lines and a transversal. You still want to look for one big, one small equal 180, or big equals big, or small equals small. When we cover this line up and all of its information, we actually don't have enough information to prove that these two lines that we're looking at, C and D, would be parallel. But that's okay, because we can cover up other things. Let's move this. And again, You will be moving your finger or your piece of paper that's covering it up. Let's look here. Again, we are focusing on C and D. We now have a couple of angles. We've got a big and a small. Follow this pattern. We don't have any of the same yellow ones matching. We don't have any of the white ones matching because we only have one of each, but we do have a big and a small. Well, 100 plus 80 definitely adds up to be 180. So what we can say here is that C will be parallel to D. That takes care of these. But do we know about the other ones, the vertical ones, E and F? Let's take a second and rotate this. By covering this up right here, do we know if E and F are parallel? Take a second to think about it. What do we think? I say, if we stick with highlighting our big angles, we don't have any big angles that match. We don't have any small angles that match. So big, big, small, and small doesn't work here. But one big plus one small does not equal 180. This equals 185. So we would say E is not parallel to F. Not parallel. These are some good basic examples and some good strategies you can use. One final strategy. If we go back here to our very beginning, I'm going to show you a trick that you'll also be able to use on your SOL. This is our friend, the ruler. If you got to see the last SOL video, we used this ruler to show if things were parallel or not, because you can take a ruler, set it equal to whatever, slope that you have, and then move the ruler without changing its slope at all to see that these would line up perfectly. If we try this on another one of these diagrams, let's go with a more complicated one, right here. Instead of doing the big, the small, the 180, check it out. Take your ruler, line it up so that it has the same direction that your line does. See if it matches the other ones, because for the most part, all of your diagrams on the SOL are going to be perfectly to scale. Again, we didn't change what direction this was going in, and you can see that your ruler is going to intersect this line. It just crosses it over, it makes an X. Doesn't work, but it does match up with this one. Remember, as long as it's going in the same direction, it's never going to intersect or touch. Those lines, L and N, the ones that fit to this ruler, were parallel. You will be given a ruler, a digital ruler like this, when you're taking your SOL. Please use it. Good luck.